All right, college algebra students. In this video, we're going to look at the first part of the midterm exam review, version A, so numbers 1 to 13. Let's jump in. So number 1 here, when we have a product to a power, every number and every variable inside the parentheses gets raised to that power. However, before I do that, I want to get rid of that negative exponent, and I'm going to move it down as an entire group. So you could raise 12 to the negative fourth power, and you could raise x to the negative fourth power, and so on. But you could also just move that entire group there, I guess, down to the denominator. And when you do that, the exponent of negative 4 becomes positive 4. Now, because these are the same exponent, if you want, it's not necessary, but if you want, you can make it a quotient raised to the fourth power, and you can reduce before you evaluate the exponents. So it is totally up to you. You could also just start raising everything to the fourth power. So entirely up to you what you prefer. So I made it into a single, or I made it into a quotient here, raised to the fourth power. I am going to reduce what's inside the parentheses. So 3 and 12 share a common factor of 3. So I can reduce that to 1/4. For the x variable, I am going to take 4 minus 1, because x to the first is what we've got there in the denominator. If we don't see an exponent, it's assumed to be 1. So for the x variable, I'm going to take 4 minus 1, which is 3. And so I'm going to have an x to the third, and it's going to be up in the numerator. I always take big exponent minus small exponent, and then I put it where the larger exponent started. So for the y variable, I'm going to do 5 minus 3, which is 2. So I'm going to have a y squared, and it's going to be in the denominator because you had a y to the fifth down there. All right, so let's show my reduced fraction here. So I've got an x to the third up in the numerator, and then a 4y squared in the denominator. Finally, I'm going to now raise everything to the fourth power. When you raise a power to a power, we multiply those exponents. So our numerator is going to become x to the 12th. And the denominator, 4 to the fourth power is 256. And it would be y to the 8th. Once again, I multiplied because it was power to a power. All right, let's look at the next one. So for this one, what I like to do with the numbers is I like to make a factor tree. And with it being a square root, I'm going to look for 2 of a kind. If you have a factor that appears twice, you can move it in front. So we've got, let's say 36 times 2, I don't know. You could also start with 8 times 9, whatever you want to do. We're going to get the same prime factorization no matter how you start. Let's see, 36 is 6 times 6. Actually, if you want to stop there, we've already got 2 of a kind. I might just stop there. Even though 6 isn't a prime number, if you broke it down further, it would be 3 times 2 and 3 times 2. So you'd have 2 3s and 2 2s. So it doesn't necessarily have to be 2 prime numbers that we see that are 2 of a kind. So I might just stop here and I have 2 of a kind. And so I'm going to bring a 6 in front of the square root. So we're going to go step by step here, but square root 72 simplifies to be 6 square root 2. I'm getting the 2 because I've got this 2 over here that is all by itself, no 2 of a kind there. Now with the variables, so the square root of m to the 11th, what I like to do with the variables is I like to take the exponent and divide by the index. And our index is a 2 when you've got a square root. You don't see it there, but it's assumed to be 2. 11 divided by 2 is 2 goes in 5 times, which is 10. And the remainder is 1. What that means is that you can bring 5 m's in front and you would have a single m left underneath. So the 5 is the exponent on your variable in front, and then your remainder is what stays under the square root. And then finally, n to the 24th, square root n to the 24th. If we take 24 and divide by 2, 2 goes in 12 times, which is 24, and there is no remainder. What that means is that you can bring 12 n's in front, and you will have no n's left underneath the square root. The last thing I need to do is just put this together. So the 6 is in front, m to the 5th is in front, n to the 12th is in front, and then left underneath we've got a 2 and an m. So that is our simplified square root. All right, number 3. So first thing I'm going to do is I notice a bunch of GCFs. And so when we're factoring, the first thing we want to do is factor out a GCF if there is one. So I notice in the first numerator, I've got a GCF of 2. So let me go ahead and pull that out. In the first denominator, no GCF, so I'll just leave it as is. In the second numerator, I notice a GCF of 3. And in the second denominator, I notice a GCF of 2. So first, I'm just going to factor out my GCFs. Now, when you are multiplying two fractions, you do not need a common denominator. We're just going to factor all of these, and we're going to look to cancel any common factors in the numerator and denominator. All right, so back up to the first numerator. X squared minus 49 is a difference of squares. It will factor as x minus 7 times the quantity x plus 7. So that's our difference of squares. The first denominator is a difference of cubes. So let me write that formula down for you. So a to the third minus b to the third can be factored as a minus b times the quantity a squared plus ab plus b squared. For this problem, our a is just an x, and our b is 7. That one, your calculator would be helpful. When you see an x cubed, you definitely want to look to see if it's a sum or difference of cubes. And 343 is 7 times 7 times 7. So you could just kind of test it out in your calculator to see if 343 is a perfect cube. You could also use the cube root button if you wanted to on your calculator. Take the cube root of 343. So our b is 7. Our b is not a negative 7. The formula accounts for the fact that we've got a difference. So don't make your b negative 7. It's going to be a positive 7. All right, so it factors as x minus 7 times the quantity x squared plus 7x plus 49. All right, moving to the second fraction. I pulled out a 3, remember. So I'm going to keep that as 3 times the quantity x plus 4. I can't factor that any further. And then in the denominator, I can factor further. So I've got a trinomial. The leading coefficient is a 1, which means I can look for two numbers that add to 11 and multiply to 28. We can use that quick factoring method when we've got a leading coefficient of 1. And so those two numbers would be 7 and 4. Okay, now to finish, we just look for common factors in the numerator and denominator. So I've got an x plus 4 and an x plus 4. I can cross cancel an x plus 7. Looks like I can also cancel x minus 7. And I can also cross cancel these 2's as well. So don't forget to reduce your numbers too. I believe that's it. I think I got rid of all the common factors. So the only thing left in the numerator is a 3. And in the denominator, we've got that trinomial x squared plus 7x plus 49. Okay, number 4. For number 4, we do need a common denominator. I'm just going to rewrite this and kind of space things out a little bit so I can show what I'm going to multiply by. So unlike number 3, when we were multiplying and we do not need a common denominator, when you add or subtract, you do need a common denominator. So looking at the numbers there in the denominator, one denominator has a factor of 2 and the other has a factor of 5. So if I want to make the numbers the same, I'm going to have to multiply first fraction top and bottom by 5, second fraction top and bottom by 2. Okay, that made the numbers the same. I also need the variables to be the same. So I'm going to look at the a variable. The first denominator has 1a, but the second one has 3, a to the third, a times a times a. So if I want the a's to be the same, I need to multiply the first fraction by a squared. That way both a's will be a to the third power. So I have to give the first denominator 2 additional a's. Now I look at the b's. The first denominator has 14 of them, and the second denominator only has 13. So I need an additional b over here. Now that should do it, but let's double check here. So we've got 5 times 5a squared, which would be 25a squared. And this is over 10a to the third, b to the 14th, plus 9 times 2b would be 18b. And then we've got 10a to the third, b to the 14th. So yes, I do have a common denominator. Once you have a common denominator, you add numerators and you retain your common denominator. I'm going to retain my common denominator, add my numerators. When I add, they're not like terms. So the best I can do is just kind of show the sum there up in the numerator. Okay, number 5. So for number 5, we want to solve for b. And the first thing I'm going to do is I'm going to clear the fractions. So let me kind of space it out again. So one thing we can do if we have an equation, it doesn't work unless we have an equation, but if we have an equation, if we get a common denominator, then we can get rid of that common denominator. We can do that because we're going to multiply both sides of the equation by that least common denominator. So what I'm going to do is I'm going to multiply the first fraction top and bottom by BC, second one top and bottom by AC, and third one top and bottom by AB. So by doing that, every denominator is ABC. I've got BC over ABC plus AC over ABC equals AB over ABC. Now, because I have an equation, I've got an equal sign, what I could do now is I could multiply both sides by ABC. And when I do that, all of my denominators cancel. So if you've got an equation, you can get a common denominator and then cancel that common denominator. So I need to solve the equation in the numerators, which is this. For B, I should say. Solve it for B. So to solve it for B, I might do it slightly different than what I did in the solutions I posted. It doesn't matter. They're equivalent answers. But for this one, what I'm going to do is I've got two terms that contain a B, and they're on opposite sides of the equation. So if I'm going to solve for B, I need to get those together on the same side. Otherwise, I'm not going to be able to isolate B. So I'm going to subtract BC from both sides, and that way the two terms that contain a B are on the same side of the equation. And then what I'm going to do is I'm going to factor out the B, take it out. Basically, it's a GCF of the right side of the equation. So I can take it out. And then the last thing I'm going to do is I'm going to divide. I'm going to divide both sides by A minus C because the B is being multiplied times that. So the inverse operation, which would be division, will isolate our B. And so B is equal to A times C over A minus C. And if you look at the answer key, there's another answer that would be equivalent. So if you solve and you get B equals negative AC over C minus A, that is equivalent. That's the same thing. So either answer is fine. Okay, number 6. This one is a problem about an average. And to find an average, we add up the observations and we divide by how many there are. Now for this one, we're missing one. We want to figure out what score does he need on test 3 in order to have an average of 90 in the class. So we're given test 1 was a 91, test 2 was an 86, test 3 we don't know, it's a missing observation. And then we're going to divide by 3 because there are 3 tests, and we want this to equal an average of 90. So this is the equation we need to solve. Let's see, 91 plus 86 would be 177. So 177 plus x over 3 equals 90. I can multiply both sides of the equation by 3, and that will get rid of that denominator there. So multiply both sides by 3. We get 177 plus x equals 270. And then we can subtract to finish our 177 from both sides, and we're going to get that x is 93. So if this student gets a 93 on the third test, his average would be a 90. All right, number 7. So number 7, we've got a mixture problem. We have 2 bottles, a 9% concentration and a 5% concentration, but what we want is an 8% concentration. We also want to end with 100 milliliters of liquid. So I'm going to let X be the amount of the 9% bottle that we're going to use. And I'm going to let Y be the amount of the 5%, because those are the 2 bottles that we have. The 8% does not appear as one of our variables. That's what we want. We don't have a bottle of 8%. We just have a 9% bottle and a 5% bottle. So if you checked out the solutions that I posted in Ivy Learn, I did it the way our book does it. But for this video, I think I'm going to use a system of equations, which is not the way our book does it, but it's the way I like to do it. So first is, our first equation is going to be x plus y equals 100. We need to end with 100 milliliters. So however much liquid we pour from the first bottle and however much liquid we pour from the second bottle, they need to add to 100 milliliters. So my first equation is going to be x plus y equals whatever the total liquid is that we desire. The second equation is going to make the concentrations work out. So if you take 9% as a decimal and you multiply times the amount of liquid that you're going to pour from that bottle, this will tell you how much of the first bottle, how much of the liquid that you're pouring from the first bottle is the active ingredient, which I guess is acid, it says in this problem. So if I take 0.09 times the amount of liquid I'm going to pour from the first bottle, that will give me how much acid comes from that bottle. Then I'm going to do the same thing with the other bottle. And I'm going to set this equal to what I want. I want an 8% concentration, and I also want 100 milliliters. So the way that I have written out that second equation, that is to ensure that the active ingredient is mixed properly. So you've got 9% of what comes from the first bottle plus 5% of whatever comes from the second bottle, and that needs to equal 8% of our total liquid so that we've got the correct amount of the active ingredient. So the first equation is to make sure the total liquid that we want measures out, and then the second one is all about the active ingredient, which in this case is acid. Now before I go on, another thing you can do, and I often do this with my students, is as long as you're consistent, if you don't want to work with decimals, you don't have to. So if you want to just make it this equation, 9x plus 5y equals 8 times 100, that works. Basically what I'm doing is I'm just multiplying both sides of this equation by 100, so it moves, you know, all the decimal points 2 places to the right. So that's okay, just be consistent. So whatever you want to do, you could also leave the decimals in there. And by the way, 8 times 100 is 800, so I might just write it like that. Okay, now to solve our system. To solve our system, I am going to multiply the first equation, both sides, by negative, I could pick either -9 or -5. How about -9? Why not? So the reason why I pick -9 is because when I then multiply both sides by -9, and then I'm just going to copy my second equation. So I'm not changing the second equation, I'm just copying it. Notice that my coefficients on the x variable are opposites. And that's helpful because I'm going to choose to use elimination. And for elimination, we add the 2 equations together. And when you add a negative 9x and a positive 9x, they eliminate or they become 0. And so I have now just negative 4y equals negative 100. And then I can pretty quickly solve for y. So y is 25. Then to finish and solve for x, I take my answer for y and I plug it in to one of the two equations. How about the first one? It's a pretty basic equation. So, oops, should be 25. I was kind of doing some math in my head there. All right, so our y is 25. And so I plug 25 in for y, and I get x equals 75. Now, at the end here, I just encourage you to make sure that you know which represents x and which represents y. So if the question only asked for, how much of the 9%, you got to make sure you know which is the 9%. And the way I define my variables, for me, the 9% is the x value. So we've got 75 milliliters of the 9% and 25 milliliters of the 5%. So just make sure you know which is which. If it now this one asks for both, but if it only asks for one or the other, you just want to make sure you report the correct answer. All right, number 8. To complete the square, the first thing we're going to do is we're going to divide both sides of the equation by 3. When we complete the square, we need the coefficient of x squared to be 1. So I divided everything by 3. Okay, next thing I'm going to do is I'm going to move the constant over. Constant is going to be on the other side. So we have x squared minus 8x equals 11. To complete the square, we take the coefficient of x, and sometimes known as b, if you want to call it the b, like if you have ax squared plus bx plus c. So we take the b, or the coefficient of x, we cut it in half, which is really dividing by 2, and we square the result. And that's what we're going to add to both sides of our equation. So for this problem, our b is negative 8. When I cut it in half, I get negative 4. And then when I square, I get positive 16. We're always going to end up adding a positive number. So we're going to add to both sides because you're squaring. So you're not going to ever get a negative. It's always going to be a positive. So I'm going to add 16 to both sides. Make sure you add to both sides. Otherwise, the math police are going to come after you. I'm just kidding. No, we got to make sure we add to keep the balance there. Now, on the right, we'll combine like terms. 11 plus 16 is 27. And on the left, we are going to factor. And we, as long as you've done your math correctly, you have created a perfect square trinomial. And so it will factor into the square of a binomial. In this case, it's going to be x minus 4 quantity squared. So you can see that I would just tell my students, look for two numbers that add to negative 8 and multiply to 16, and that would be a negative 4 and another negative 4. So instead of writing it as x minus 4 times the quantity x minus 4, we can write that as x minus 4 quantity squared. All right, next up, square root both sides. This is known as the square root property. You do need a plus or minus. Anytime we take the square root of two sides of an equation, we use a plus or minus. So square root both sides. The square root of x minus 4 quantity squared is x minus 4. And the square root of 27 is 3 square root 3. I can show my work over here. 27 is 9 times 3. 9 is 3 times 3. And whenever you have two of a kind, you can bring that number in front. So I've got two of a kind right here. And so a 3 comes in front and a 3 also stays under. And then finally, we are going to add 4 to both sides in order to isolate our x. And so final answer is x equals 4 plus or minus 3 square root 3. I did choose to put the 4 in front of the plus or minus. That is the proper way to write it. It's not wrong if you put it in the back. We just put it in front so that there's no confusion about whether it's under the square root or not. Okay, who's having fun? I am. All right, number 9. This is another one where I'm going to clear fractions first. So we've got, I'll make it x squared over 1 minus 4x over 3 minus 1 over 9 equals 0. You could do 0 over 1 if you want, yeah, it's still just going to be 0 over there, but whatever. Okay, so because this is an equation, if I can get every denominator to be 9, then I can cancel those denominators. So I could write this as 9x squared over 9 minus 12x over 9 minus 1 over 9 equals 0 over 9. And then I could multiply both sides of the equation by 9, and all my denominators will cancel. So only do that if you have an equation. So the quadratic equation that I'm going to solve is 9x squared minus 12x minus 1 equals 0. Okay, that looks much better than what the original equation was. To solve this, it's a quadratic equation. I could try to factor if I want to. It actually won't factor though, but we would have to use the AC method of factoring, so it doesn't factor quickly. It actually doesn't factor at all, but even if it did factor, it wouldn't factor pretty fast. So I'm going to use the quadratic formula. So I'm going to let A be 9, B is negative 12, and C is negative 1. And my quadratic formula is negative B plus or minus the square root of B squared minus 4AC all over 2A. So in front of the plus or minus is negative B. Since B is already negative, I'm going to make it a positive 12. And then we're supposed to square B minus 4 times A times C, and then all over 2 times A. So we've got 12 plus or minus the square root of, my denominator is going to be 18. So I'm going to pull up a calculator. This is a graphing calculator, but I'm not going to use any of the graphing features. I'm just going to type in negative 12 squared minus 4 times 9 times negative 1, just to show you that your scientific calculator can give you the answer. So 180 is our answer, or is our radicand, I guess, or discriminant, if you want to call it that. So I squared negative 12 to get positive 144, and then it would be plus 36 because it's actually minus a negative 36, so we end up adding 36. All right, so to reduce, we do want to reduce, but before we reduce the 12 and the 18, I can't reduce the 12 and the 18 until I simplify my square root, because I've got to find a common factor in all three of those terms. So let me look at the 180. I'll show it up here. So 180, let's see, 180 is 18 times 10, and 18 is 9 times 2, and 9 is 3 times 3, and 10 is 2 times 5. So it looks like I've got a pair of 2's, and so I can bring a 2 in front. And I've also got a pair of 3's, and so I can bring a 3 in front. So in front of my square root is going to be a 6. I multiply the 2 and the 3. And then under I'm going to have a 5, because I've got a little loner 5 that doesn't have a pair, or doesn't have a buddy to be with. And then to reduce, I look at the 12, the 6, and the 18. I notice that they are all divisible by 6. So I'm going to reduce by a factor of 6. And my final answer then would be 2 plus or minus square root 5 all over 3. Okay, number 10. So number 10, we've got the square of a complex number minus a complex number. When we square a complex number, we write it twice and we FOIL. When you subtract, just be careful. Remember that you are subtracting both the 9 and the negative 2i. When you subtract a negative 2i, you get a positive 2i. So just be careful with that. Usually students have no trouble subtracting the 9, they just forget to change the sign of the imaginary number inside the parentheses. All right, when I FOIL, I get 36 plus 30i plus 30i plus 25i squared. Let me go ahead and just copy the minus 9 plus 2i in the back. I'm just going to copy that. Okay, now let me go ahead and I'll combine some like terms. I'll also, well, you know what? I'm going to combine like terms in the next step. I'm just going to rewrite everything, but I'm going to deal with that I squared. So since I squared is negative 1, I can turn that 25i squared into 25 times negative 1. And so that's why I made it minus 25. So I squared is negative 1. All right, then to finish, let me go ahead and combine my like terms. I've got a 36, a negative 25, and a negative 9. I'll bring those together. And then I've got a 30i, a 30i, and a 2i. So I'll bring those together. So let's see, 36 minus 25 is 11. 11 minus 9 is 2. 30, 30, and 2 would make 62. So final answer is 2 plus 62i. All right, we're going to do 3 more in this video, and then the others are in the second video. When you're dividing two complex numbers, the way we do this is we multiply the top and the bottom by the conjugate of the denominator. The conjugate of 4 plus 3i is 4 minus 3i. We just change the sign in the middle. This is because when you multiply two conjugates, two complex conjugates, you get a real number. So we're going to get a real number down there. And just remember that whatever you multiply the denominator by, you also have to multiply the numerator by. So you got to multiply by the same thing, top and bottom. All right, in the numerator, when I FOIL, I get 12 minus 9i minus 20i plus 15i squared, because we have a negative 5i and then a negative 3i, so two negatives make a positive. In the denominator, we've got 16 minus 12i plus 12i minus 9i squared. In the denominator, the two middle terms cancel, and that's always going to happen with conjugates. So we get rid of those middle terms. Let's see, in the numerator, let me go ahead and combine the middle terms. I can make that a negative 29i. And then I'm also going to replace I squared with negative 1. Same thing in the denominator, I squared is negative 1. So I want to replace I squared with negative 1. This makes my numerator 12 minus 29i minus 15. And it makes my denominator 16 plus 9. Then I'm going to combine my like terms. 12 minus 15 is negative 3. And 16 plus 9 is 25. Now we're not quite done. There's one extra step, and that would be we want to write our answer in the form a plus bi. Basically, that just means they want you to split it up into the real number and the imaginary number. And the way we do that is we just write what we've got in the numerator. We write them each individually over the denominator. So final answer is negative 3/25 minus 29i over 25. So just make sure you split it up at the end. Okay, number 12 is an absolute value equation. To solve, we want to isolate the bars. And to do that, sometimes I'll write like B for bars. So the equation is 3 times the bars plus 14 equals 29. And just like we would begin to solve this equation on the right by subtracting 14, that's how you begin this equation over here on the left. So we've got 3 times the bars equals 15. So 3 times the bars equals 15. So just like you would divide both sides by 3, if you were trying to solve the equation 3b equals 15, same thing over here. To isolate the bars, I'm going to divide both sides by 3. And so we get the absolute value of 2x minus 1 equals 5. Once you have your bars isolated, you create 2 equations, assuming that the number over on the right is positive, which it is in this case. And so our 2 equations are 2x minus 1 could be 5, or 2x minus 1 could be negative 5. So I'll solve these pretty quickly. I'm sure, or I'm hoping that you can solve these on your own without much trouble. So our 2 solutions are 3 and negative 2. They both work. If you plug in 3, you get a 5 inside the bars, and the absolute value of 5 is 5. If you plug in negative 2, you get negative 5, but that's okay because that's inside absolute value bars. And the absolute value of negative 5 is still 5. All right, last one in this video. And then check out my other video after this. For this one, we're going to isolate the square root by subtracting 7 from both sides. And then to get rid of the square root, we're going to square both sides. So I'm going to square and square. We don't do a plus or minus when we square both sides, only when we square root both sides, not when we square. So when you square the square root of 3x plus 4, you get 3x plus 4. When you square 4, you get 16. And then we're just going to solve this equation by subtracting 4 and dividing by 3. And so we get x is 4. This is a good solution, but I am going to show you just with a quick check. When we have radical equations with an even index, we do have the potential of getting an extraneous solution. You will see that in the next problem, which is the first one of video 2. So you do want to check your answers here just to make sure. If you can check in your head, that's fine. You don't have to show this work if you don't want to. But I'll just show you that this one is a good solution. We get square root 16 plus 7 equals 11, and the square root of 16 is 4. And so yes, it does work out. We end up getting 11 equals 11, which is good. But like I said, in number 14, we're going to see what an extraneous solution would look like for these. Well, thank you for watching, guys. Good luck on your exam. Oh, but check out my other video.